6.3 Measures of central tendency for group data. Recall. The measures of central tendency are value which is representative of a set of data. The measures of central tendency involve calculating of mean, median, and mode. Now let's look at how to find the means or x-bar for the group data. The formula for the means of a frequency distributions can also be used to provide an estimate of the sample mean of a set of group data. The formula is x bar equal to summations of fx divided by summations of f, where summations of fx is the summations of frequency times midpoint for each class, and summations of f is the total frequency or observations n. Next, let's look at how to find the mode or capital M for group data. So, the mode of a group data can be found by using formula. The formula is given by M equal to Lm plus in the bracket D1 divided by D1 plus D2 times C, where Lm is the lower boundary of model class. D1 is the difference between frequency of model class and the class before. D2, difference between frequency of model class and the class after. C, width of the model class. And you must know that the model class is determined by the highest frequency among the class intervals. Next, let's look at how to find the median or small m for group data. The median is the middle value, which implies that 50% of the value are less than or equal to the medians. M equal to Lm plus n divided by 2 minus capital F m minus 1 divided by small fm times C, where Lm is the lower boundary of median class. Capital F m minus 1 is the cumulative frequency of classes before median class. Small fm is the frequency of median class. N is the total frequency or observation summations of f. C is the width of the median class. You must know that the median class is determined from the location's middle observations among the class intervals. Example 7. Data obtained from the speed limits of vehicles at a particular area on the Plus Highway during the recent festival season is given below. The speed in km per hour and the number of vehicles. For the first class, the speed is 90 until 95 km per hour with the number of vehicles are 12. For the second class, 96 until 101 km per hour with the number of vehicles 4. Next, 102 until 107 km per hour with number of vehicles 19. Next, the speed is 108 until 113 km per hour with the number of vehicles 35. Next, 114 until 119 km per hour with the number of vehicles 26. For the last class, the speed is 120 until 125 km per hour with the number of vehicles are 14. So, based on the above informations, number 1, calculate the mean, median, and mode for the speed limits of the vehicles, rounded the speed limit to the nearest kilometer. Then, interpret the answer. Number 2, hence find the squareness of these distributions. Before we can answer number 1, let's try to recall the formula for means, medians, and mode. So, the formula for the means is x bar equal to summations of fx divided by summations of f. And the formula for the medians is m equal to Lm plus in the bracket n divided by 2 minus f m minus 1 over fm times c. And the last one, let's recall the formula for the mode, which is m equal to Lm plus in the bracket d1 divided by d1 plus d2 times c. Based on the formula of mean, median, and mode, you must expand the table to find the certain informations. You can expand the table to get the cumulative frequency, the midpoint, and fx. So first, let's find the cumulative frequency of each class. For the first class, the cumulative frequency we can get from the frequency here is 12. For the second class, the cumulative frequency is, you can take 12 plus 4 equal to 16. Okay, for the third class, the cumulative frequency will be 16 plus 19, which is 35. And next, 70, 96, and for the last class is 110. For the midpoint, we can find the midpoint of the first class by taking 90 plus 95 divided by 2, which is 92.5. You can repeat the process. For the second class, the midpoint is 98.5. The third class, 104.5. Next, 110.5, 116.5, and for the last class, 122.5. Next, we want to find fx, but we just need summations of fx. So you can find summations of fx by using calculator, which is you should get 12,101. Still on question 1, let's try to calculate the mean. So to calculate the means, we should know this formula, x bar equal to summations of fx divided by summations of f, where define summations of fx, which is 12,101, and summations of f is 110. We can substitute these two informations in this formula. 12,101 divided by 110, you should get 110 km per hour after we rounded the speed limit to the nearest kilometer. Then you must interpret the answer. To interpret the mean, we can say that therefore the average speed limit of vehicles at a particular area on the plus highway is 110 km per hour. Okay, next we try to find the medians. Okay, how to find the medians? We will use the formula m equal to Lm, the lower boundary of the median class, plus the bracket n, which is the total frequency, divided by 2 minus capital F n minus 1, which is the cumulative frequency of the class before median class, divided by Fm, the frequency of median class, times C, the class size. So before that, we must find the median class. So how to find the median class is we must determine from the locations middle observations among the class interval. So to find the middle observation, we must use the cumulative frequency, which is 12 for the first class, 16 for the second class, 35 for the third class, we have 17 for the fourth class, 19.6 for the next class, and the last class 110. So the middle observations, how to find it is by taking summations of f divided by 2. So summations of f is 110 divided by 2, which is, we know that 55th observation. So 55th observations is in here. Okay, so the median class is 108 until 113 km per hour. Okay, next we can find the other informations, which is we can have lower boundary of the median class by taking 107 plus 108 divided by 2, which is 107.5. Next, we can find n, which is equal to summations of f, which is 110. We can find fm minus 1, which is the cumulative frequency before median class. So this is the cumulative frequency before median class, 35. And then we can have frequency of the median class, which is 35. And we can have the class size. So to find the class size, we can take the upper boundary of the median class minus the lower boundary of the median class. So the upper boundary of the median class is 113.5 minus the lower boundary of the median class is 107.5. So you can calculate equal to 6. Okay, now we can substitute the informations we already get in the formula of median. So the lower boundary is 107.5 plus n, which is 110 divided by 2 minus the cumulative frequency before median class, 35, divided by frequency of the median class, 35, times the class size, which is 6. So you will get 111 km per hour after we rounded the speed limit to the nearest kilometer. Now we can interpret the answer. So interpretations for medians is 50% of the vehicles have the speed limit at least 111 km per hour. Okay, now let's find mode. Okay, to find mode, we will use the formula m equal to Lm, the lower boundary of the model class, plus in the bracket d1, the difference between frequency of model class and the class before, divided by d1 plus d2. d2 is the difference between frequency of model class and the class after, times c, which is the class size. Before that, we must find the model class. So to find the model class, we must know the highest frequency among the class interval. So the highest frequency is 35. So we can say that the model class is 108 until 113 km per hour. Next, let's find the information needed, which is Lm, the lower boundary of the model class, which is you can take 107 plus 108 divided by 2, which is 107.5. Okay, next, d1s. Okay, the difference between frequency of the model class, which is 35, minus the frequency of the class before, which is 19 equal to 16. Okay, D2, we can take the frequency of the model class 35 minus the frequency of the class after, which is 26. So the answer is 9, and the class size we already calculated before, which is 6. So you can substitute the information in this formula. We have 107.5 plus, in the bracket, 16 divided by 16 plus 9 times 6. So the answer is 111 km per hour after you rounded the speed limit to the nearest kilometer. Now we can interpret the answer. So the interpretations for the mode is, therefore, most of the speed limit of vehicles at a particular area is 111 km per hour. Number 2, hence comment on the skewness of these distributions. Before we can comment on the skewness, we must recall the value of mean, medians, and mode. So we already get mean 110 km per hour. For median and mode, we get the similar value, which is 111 km per hour. So it's enough to compare mean and mode. So we have the value of means less than mode. Since mean less than mode, we can say that the distribution is negatively skewed. Example 8. The table below shows the expenses in fuels on September 2015 for a sample of 120 workers. Here is the expenses in fuel in Ringgit Malaysia and the cumulative frequency for the first class X greater than and equal to 130, X less than 140 with the cumulative frequency 2. For the second class X greater than and equal to 140, less than 150 with the cumulative frequency 9. The third class X greater than equal to 150 and less than 160 with the cumulative frequency 20. Next, X greater than equal to 160 and less than 170 with the cumulative frequency 33. The fifth class X greater than equal to 70 and less than 180 with the cumulative frequency 54. Next, X greater than equal to 180 and less than 190 with the cumulative frequency 81. Next, X greater than equal to 190 and X less than 200 with the cumulative frequency 98. Next class, X greater than equal to 200 and less than 210 with the cumulative frequency 112. For the last class, X greater than equal to 210 and less than 220 with the cumulative frequency 120. So if we look at the first question, question A, construct a frequency distribution tables for the above distributions. And question B, calculate the mean, medians, and mode for the above data and interpret the answer. Hence, describe the shape of the distributions of the data. Now, let's solve question A. Construct a frequency distributions table for the above distributions. We refer to these tables. So, to construct a frequency distributions table, we must have class, cumulative frequency, midpoint, frequency of each classes, and frequency times the midpoint, fx. For the class, you can copy back from the previous table. So we have x greater than equal to 130 less than 140. Next, x greater than equal to 140 less than 150. The class x greater than equal to 150 less than 160. Fourth class x greater than equal to 160 and less than 170. Next, we have x greater than equal to 170 less than 180. Next class, x greater than equal to 180 less than 190. Next class, x greater than equal to 190 less than 200. Okay, next class, x greater than equal to 200 less than 210. And for the last class, x greater than equal to 210 and less than 220. Okay, next for cumulative frequency, you just copy back from the previous table. So for the first class, 2, second, 9, next 20, 33, 54, 81, 98, 112, and for the last class, the cumulative frequency is 120. Okay, next, let's try to find the midpoint of each classes. For the first class, to find the midpoints, you just need to take 140 plus 130 divided by 2. So we will get 135. Okay, for the second class, you can take 150 plus 140 divided by 2, which is you should get 145. And you can repeat the process for each classes. So we have 155, midpoint of the third class. Next, 165, 175, 185, 195, 205, and for the last class, 215. Okay. Next, let's find the frequency of each classes. To find the frequency, you can refer to the cumulative frequency. For the first class, to get the frequency, you can refer to the cumulative frequency of the first class, which is 2. To get the frequency of the second class, we can take 9 minus 2 equal to 7. Okay. The frequency for the third class we can get by taking 20 minus 9, which is 11. You can repeat the process. You should get 13, 21, 27, 17, 14, and for the last class, the frequency is 8. So the summations of frequency is 120, which is similar to the cumulative frequency of the last class. Okay, now let's find fx. Okay, you just need to find the summations of fx to be used later. By using calculator, summations of fx is 21,710. Now, let's proceed to question B. Calculate the mean. So, let's find the mean. To find the mean, we will use this formula. X bar equal to summations of fx over summations of f. We already get the value for summations of f equal to 120 and summations of fx equal to 21,710. So you just need to substitute in this formula. So x bar equal to summations of fx 21,710 divided by summations of f, which is 120. You should get Rm 180.92. Next, the question also asks you to interpret the answer. So, to interpret the mean, you can say that therefore the average expenses in fuel is RM 180.92. Still on questions B, let's calculate median. So to calculate median, we will use this formula, M equal to LM plus N divided by 2 minus capital F M minus 1 divided by FM times C. So, before that, we must find the median class. So, how to find the median class? Median class can be determined from the location's middle observations among the class interval. So, we just need summations of F divided by 2 to find the middle observation. So, summations of F is 120 divided by 2 equal to 60 observation. So, where is the 60 observation? You can refer to the cumulative frequency, which is around here. So, we can say that the median class is X greater than equal to 180 less than 190. So, next, we can find LM, which is the lower boundary of the median class. We can take 180 plus 180 divided by 2, which is 180. Next, we can find N, which is equal to summations of F equal to 120. Next, we can find LM minus 1, which is the cumulative frequency of classes before median class. So, the value is 54. Okay, next, we must find FM, which is frequency of the median class. The frequency of the median class is 27. Okay, the last one, we need to find class size. We can take the upper boundary of the median class minus the lower boundary of the median class. So, the upper boundary of the median class is 190 minus the lower boundary of the median class is 180. So, you should get 10. Since we already get all the informations needed, so now we can substitute in the formula. So, M equal to LM 180 plus in the bracket N divided by 2, which is 120 divided by 2 minus cumulative frequency of classes before median class 54 divided by FM 27 times C, which is the class size 10. So you should get RM 182.22. So now you need to interpret the answer. So we can say that 50% of the 120 workers spend at least RM 182.22 in the fuels. Now, let's try to calculate mood. We can use this formula to calculate mood. M equal to LM plus in the bracket D1 divided by D1 plus D2 times C. Before that, we must have the model class. So how to find the model class? You can determine the model class by the highest frequency among the class interval. So the highest frequency is 27. Therefore, the model class is x greater than equal to 180 less than 190. Next, let's find Lm, the lower boundary of the model class. We can take 180 plus 180 divided by 2, which is 180. Next, D1, which is the difference between frequency of the model class 27s and the class before 21. So 27s minus 21 equal to 6. Next, find D2, which is the difference between frequency of the model class 27s and the class after 17, which is 27s minus 17 equal to 10. The last one, let's find C, which is the class size of the model class. Okay, we already find the class size before, which is C equal to 10. Since we already have the information needed, we can substitute in the formula. So M equal to Lm 180 plus in the bracket D1 6 divided by 6 plus 10 times C class size, which is 10. So you should get Rm 183.75. So now let's interpret the answer. We can say that therefore most of the 120 workers spend Rm 183.75 in fuels on September 2015. Now let's try to answer the last part of question B, which is describe the shape of the distributions of the data. Okay, to describe the shape of the distributions of the data, we can recall the value of mean, medians, and mode. Okay, based on the value of mean, medians, and mode, we can say that mean less than median less than mode. Therefore, we can say that the distribution is negatively skewed.